So, y'all know that I've been talking about how important perfect square trinomials are, and today is the reason why. We are making perfect square trinomials in order to complete the square. So if I said x squared plus 10x plus some value of c makes a perfect square trinomial, what do you think that value of c would be? So we know that this would be, if I were to factor this trinomial, I know I'd be x times x, right?
Yeah.
So we have to find half the value of the b value, half the b value, 5. Okay, so that would mean if I FOILed, it would be x squared plus 5x plus 5x plus what? What's 5 times 5? 25. So x squared plus 10x plus 25 is my perfect square trinomial. So c is 25. Okay? And if I factored that, it would be what we had here, except I would write it x plus 5 squared. So using what we talked about here, what do you think the c value would be on number 2?
49.
49. How did you get that?
Take up
Half of 14 squared equals 49. So if I factor that, x plus what squared would be my factor? 7. So let's look at number 4. This one says x squared minus 8x. So how would I find out that c value? 16. So my c value is 16, but this time when I factor, it's going to be minus. Finding this c value is what we call completing the square, because we want a perfect square trinomial, but this part is unknown at that point. And so when we find out what it is, we have a perfect square trinomial, meaning that if we drew the algebra tiles, we would have a square, like I showed you guys that one time. Okay. Now all of these, you notice that all of these start with x squared. Okay, and I'm going to leave it at that for now. Now notice on the back, when you get this, there are some that don't have a equals 1, but you can still make them perfect squares. Okay, so I want to point that out to you, but we're not going to go over that today. So remember, I was talking about when we draw the algebra tiles, we are making a perfect square. So this has x squared plus 6x. I want it to be x squared plus 6x plus some number. What would that number be? 9. Because to complete this square, we have to add 9. So this is x plus 3 times x plus 3. So that's a 9. We write that expression in factored form. It's going to be x plus 3 squared. Now, why do we do it? Because one of the ways that we can solve quadratics is by using a square root method. So, when this was the case, what did I add here to make this a perfect square trinomial? We added 9. And then I factored this and I got x plus 3 squared, but now it's not just an expression, I have it equal to what? 9. So notice when you add to 9 to this side, I had to add it over here too, right? Because it's still an equation. When we solve, now we can solve by using a square root. So the square root here, what's the square root on the left side? X plus 3. Because the square root just undoes the square. Equals positive or negative 3. Because remember, negative 3 times negative 3 is also 9. And remember, how many possible solutions can we have with a quadratic? 0, 1, or 2. So now, to get x by itself, what would I do? Subtract 3 from both sides. So, and I'm going to write this x equals negative 3 plus or minus 3. So in our solution set, what's negative 3 plus 3? 0. What's negative 3 minus 3? Negative 6. Now this is super nice because they came out to integers. Do you think that's always going to be the case? Probably not. Let's look over here. Let's do another one. Now this was one that was on number 4 that it started on the previous piece of paper that we did. We said x squared minus 8x, and what did we find out was C? 16. So if we add 16 to both sides, we factor, this became what? X minus 4 squared equals 16. Square root both sides. So x equals 4 plus or minus 4. What's 4 plus 4?
8.
And what's 4 minus 4?
0.
Okay. So those have been two pretty straightforward examples. Let us do number 5. If I'm going to complete this square, what are we going to add to both sides? 4. We're going to add. And now, are we ever going to subtract when we're completing the square? No, because anything times itself is going to give us a positive. So plus 4. So we're going to factor. We factor here. What do we get? X minus 2, because half of negative 4 is negative 2. Squared equals 12. So what's my next step? Square root both sides. So we get x minus 2 equals, can I take the square root of 12?
Yeah. It would be 2 square root 3.
Ooh. So how did you get 2 square root 3? You simplify the radical, because square root 12 is really square root of 4 times the square root of 3. Now what are we missing here? Plus or minus, because we're taking the square root. Okay, so we are going to keep our simplifying the radical, so unit 7 comes back into play here. Okay, last step, add 2. Now, whereas before we had something to simplify, here we've already simplified our radical. We can't add or subtract those things, so it's just going to be x equals 2 plus or minus 2 square root 3. No, there's still 2. Now, if this had context, could we find out what, say this is like a rocket launching and we ask how much time it takes. We might say, okay, 2 plus 2 square root 3, I get 5.46 or 5.5, depending on where we ask you to round. And then you would do 2 minus 2 square root 3. Negative. So depending on context, I could be like, well, that answer would not be valid in that situation if I'm talking about time. But if we're just talking about distance, forward, backward, we could use that. But that's where we have an irrational solution or 2, and so we'd have to round probably. For the beginning, we're going to keep things in simplified radical form. Okay, let's look at number 6. This one has the same start as this one. So when we're adding, we're still going to be adding 4. But when I do that, what happens over here? So if I factor, I get x minus 2 squared equals negative 5. My next step is to square root. But what did we talk about the other day? You can't have a square root of a negative number. So that tells me what about this quadratic? It tells me that there is no real solution. Now think about what this graph looks like. Remember how we talked about perfect square trinomials have the vertex on the x-axis? And this one has a positive x, so it's opening upward. Is there ever a time that it would equal -5, which is below the x-axis? No. So there we are, marrying those two ideas. Okay? Now, number 7, what do we do if they have a C value already here? Yeah, let's go ahead and move it to the other side and say, you know what, I don't want to deal with that right now, so if I'm going to get rid of this 13, I'm going to have to subtract it from both sides. We have x squared minus 12x, and I'm going to leave a little space because remember, I want to complete the square, equals -13. Okay. So completing this square, half of -12 is -6. So you know what, sometimes I like to just go ahead and factor it when I know what half of it is. And then I say square it, what am I going to add? 36. So now I add 36 to both sides. I say that equals -13 plus 36, 23. Square root both sides. Now what do you know about 23?
That is a prime number.
It's a prime number, so I can't simplify it. So x minus 6 equals plus or minus the square root of 23. Add 6 to both sides to get x by itself. X equals 6 plus or minus the square root of 23. And that's our final answer on that one. You want to do one more like that? Let's do number 9 on the inside. Because this is just practice of what we did on the front. First, remember you're going to get the quadratic into the form x squared plus bx equals, and you're going to put your c value on that side. You're going to add your b over 2 squared to both sides. You're going to factor and then solve for x. Okay? But let's look at number 9. Why do I want to look at number 9? What makes number 9 different? That one doesn't bother me so much, but we will do that. X squared plus 3x equals 1. Now,
oh, I understand. Because the half is a decimal.
Because b is odd. So completing the square works best when b is even and a is 1. Okay, that's when you really want to use it. When all those other ones that we were looking at that were non-factorable, completing the square would be a good choice when a is 1 and b is even. But what happens when I ask you to complete the square but b is odd? So remember that we're going to take b and divide it by 2. Leave it as a fraction. If I already know what half of b is. Now if I want it to be this, 3 over 2 squared is what? 9 over 4. We're going to add 9 over 4 to both sides. Now, 1 is like saying 4 over 4, right?
So,
Yeah.
13.
So that equals 13/4. Square root both sides.
You take the root of the fraction.
Yes, but if you've squared your term right here, then the bottom will always be a square number, and then you don't have to rationalize your denominator. So x plus 3/2 equals square root 13 over 2. Oh, what did I forget?
Positive or negative.
Yeah, plus or minus square root 13 over 2. Subtract 3/2 from both sides, so we get x equals 3/2, -3/2, plus or minus square root 13 over 2. Now they have the same denominator, so check this out. That's how you would write your final answer.
That's what I can do.
Well, and that is probably as much as I would do for you in class. What you'd have the rest of it is practice with answers, and then this would probably end up being your homework with answers.